In this video, we'll be looking at expanding some more binomials using Pascal's triangle. We've just been through how Pascal's triangle works in choosing the coefficients of our expansion of the binomials, and also the process of expanding binomials. So this example, we'll be going through it a little bit faster because we should be a little bit more familiar on how to lay out these expansion of binomials. So we're going to be looking at example B, and what we have now is w plus L all to the power of 6, and we want to expand this using our counting techniques of expanding binomials. So the first step is to identify the coefficients. So we've got A is our W, B is our L, and we've got N as 6. So that means everything will be choose 6. So first step, we equal it all out. So to expand this, we go 6, choose 0, and then we've got W, the power of 6, and then L, power of 0. Then we carry this on, looking at our next power, 6 to the power of 0. So that means what we have now is 6 choose 1. Now you may note that you can start seeing a pattern here. So you can write W, L plus 6 choose 2, W, L plus 6 choose 3, W, L plus 6 choose 4, W, L plus 6 choose 5, W, L plus 6 choose 6, W, L. So we've laid this out. We've got our 6 choose, R values. Now we want to assess the W's and the L's. So in this case, we had this value here. Okay, we had W to the power of 6. Okay, so we're going to decrease the W powers now. So this will be 6, and this will go to 5, 4, 3, 2, 1, and 0. So let's write that in now. So we're just doing our W powers. And this method requires you need to know how to lay it out, just so you can squeeze in all those powers. The next step is we're going to increment our L powers. We start at 0, then we should end up at 6, going up by an integer of 1. 0, 1, 2, 3, 4, and I've just double repeated 3 there, apologies. Okay, that should be 2, that should be 3, 4, 5, and 6. Now our sanity check is to go, okay, we know that all these are to the power of 6 and 0, 5 and 1, 4 and 2, 3 and 3, 2 and 4, 1 and 5, 0 and 6. If you can see a pattern, they always add up to 6. So if 2 of your numbers don't match up to make n, then something might have gone wrong. Our next step is to complete the choosers. So we're starting off with 6 choose 0. Now we can use our Pascal's triangle to do this. So we can go row 6 and the 0th term is 1. Okay, so we can use Pascal's triangle, or we can use a lookup table. So row 6 choose 0 is going to be 1. Doesn't matter which one. I prefer the lookup table, but it's up to you. 1 times by W to the 6 times by L to the power of 0. Now L to the power of 0 is 1 plus. Then we go up and we go, okay, 6 choose 1 is going to be 6 times by W to the 5 times by L plus 6 choose 2 is 15. 6 choose 3 is 20 plus 6 choose 4 15. 6 choose 5 is 6. Plus 6 choose 6, as we all know, is 1. W to the 0 is times by 1 times by L to the 6. Now we need to simplify and collect all our terms together. So 1 times W to the 6, we've just got W to the 6 plus 6W5L plus 15W4L squared plus 20W cubed L cubed plus 15W squared L to the 4 plus 6WL to the 5 plus L to the 6. So there's our final binomial expansion. Okay, I'll just highlight that in yellow there. Now, how can we check if this works? Well, we can use our class-pad to confirm. So we're going to use the expand function. So action, transformation, expand. And what we're going to do is we're actually going to type in using our coefficients. Just experiment. So we start our bracket, okay, and I'm going to put in W plus L. Now up here, we only have X, Y, Z as our variables, but we can go into the keyboard, variable, and then type in W plus L. Then we go to the power of 6, and our class-pad is going to expand that for us. So we've got L to the 6 and W to the 6. We've got them. 6L squared W. Got that one there. Or 6L to the 5. There we go. Plus 6L W to the 5. There we go. And then we have 15L squared W to the 4. We've got that one there. 20 L cubed and W cubed just there. So beautiful. Looks like it worked there. And this is why you can use the class-pad to confirm your answer. Then in the next question, we'll look at part C.